Chapter 2, Section 4 is about solving equations that have variables on both sides. This is a 2-day lesson, but by the end you should be able to solve one-step and multi-step equations with one variable, as well as model real-world problems with algebraic equations and solve it. Okay, we're going to start with this one. This is what I mean by one variable on two sides, both sides. We have an x on this side and we have an x on this side. All right, over here, if you're in class, I'll give you a copy of this, but over here we have this little cell phone for solving equations. Don't call me after midnight. Those are the letters that tell us the order that we should do things. Okay, first we want to start with any distributing, if that's an option in your equation, which in this case it's not. Okay, so then we would look at combining like terms, and that means on either side. I don't have like terms over here on the left, and I don't have any like terms over there on the right, so we can move on to that. Then we want to move a variable. We want to try to get all of our variables on the same side with all of our constant numbers on the other side. There's a couple ways that you can do this. You can just use inverse operations, and then you get to decide which one you want to move. I personally try to keep it so that I have as little negative numbers as possible, just because it seems like negatives leave more room for error. So in this case, I would subtract 2x. But let me show you what these boxes here are for. If this is something that's difficult for you, the boxes help a little bit if you can remember how to use them. So the boxes are for, over here we're going to put all of our variables. So I have a 5x and I have a 2x. Anytime that you have to cross this equal bar, you have to make that to its opposite. So instead of a 2x, this is going to become a negative 2x. Okay, on the right side, I'm going to put my constant numbers. So I have a 14, and then I have this 2, but since I crossed the center line, it's going to be a negative 2. All right, then down in the big box, we're actually going to combine what we have up top so that we can get it as simplified as possible. So I have a 5x and a negative 2x. That leaves me with 3x. Then I have a negative 2 and a positive 14, which leaves me with 12. So I now, for my equation, have a 3x equals 12. And from there, I can just separate my one-step equation by dividing by 3, and that tells me that x equals 4 in this case. Okay. Now, if you don't need those boxes, we can do it without them, just with our inverse operations. So I'm going to draw my train tracks down the middle. There's no distributing, there's no like terms on either side, so I'm going to move this 4k. In order to move it, I need to subtract it since it was positive. And the reason I chose the 4k is because I have 7k's on the left, and that leaves me with still a positive amount of k's. All right, next thing I want to do now that I have all my k's on the left is I'm going to move these constants, the 2, over to the right. They cancel here, leaving me with 3k equals negative 12. That was my move the variable and my add or subtract. Now I'm going to multiply or divide, which in this case means divide by 3. And a negative 12 divided by 3 leaves me with negative 4. Now again, just like all of the other sections in this chapter, it's a really good idea to double check to make sure you have the right answer. So you would take your negative 4 and plug it in for each of these k's. And that will tell you if you got the right final answer or not. So 7 times negative 4 is negative 28 plus 2 gives me a negative 26. 4 times negative 4 is negative 16 minus 10 is negative 26. So since they're the same, we know that this is the right answer. Next example, I'm going to rewrite it over here so we have some more room to work. Negative 3c minus 12 equals negative 5 plus 1c. Okay, I'm going to draw myself the train tracks down the middle. I don't have any distributing. I don't have any like terms on either side, so I'm going to move my variable. Because this is a negative 3c, I can make it positive by adding 3c, leaving me with a negative 12 equals negative 5 plus 4c. Now I'm going to add or subtract. In this case, I have to subtract a -5. So minus a -5 actually means that I'm adding 5 to both sides. I'll be left with 4c equals -7. And then I multiply or divide. In this case, I'm going to divide by 4. Now, I don't want the decimal for this. You can leave it as -7/4, or you can say -1 3/4, whichever makes you feel better. All right, here we go. This is a big one, and this involves all of our steps. So we're going to start with distribute. 5 times 3x gives me 15x, plus 5 times 1 is 5, and then I still have this plus 2x. 4 times x is 4x, minus 4 times 5, which is 20. Distributing done. Now on either side, I'm going to combine like terms. In this case, I have 15x and 2x, so 17x plus 5 is equal to, on the right side, my like terms are actually the constants, a -1 and a -20, so I will have 4x minus 21. Okay, there was our combined like terms. Now we're going to move the variables. I'm going to move the 4x because that will keep everything as much as I can positive. 17x minus 4x gives me 13x plus 5 equals -21. Now add or subtract. I have to subtract 5. So I have 13x equals -26. Now I multiply or divide. So I'm going to divide by 13, which will tell me that x is equal to a -2. That was an example of all of the steps, all 5. All right, this diagram gives information about the populations of 2 towns. After how many years will the populations be equal, and how do you know? All right, we need to write an equation for each one. So town A started with 3,225. Each year they're growing, so we're adding 100 people for however many years we count. So 100 times x. Town B started with 3,300 people, and they are growing by 75 people each year, and we want to know when they're going to be equal. Right? So we just wrote ourselves an equation with variables on both sides. Now we can solve it. We're going to start by distributing if there is any, but there is not. After distributing, it was combined like terms, but I don't have any of that. Then it was to move the variables. So I'm going to take away 75x, which leaves me with 3225 plus 25x equals 3,300. Then subtract 3225, because now we're at that couple and third wheel stage, the 2-step equations. 25x equals 75, and then when I divide by 25, I find out that after 3 years, these towns will be equal at the rate that they're currently growing. It takes a graphic designer 1.5 hours to make one page of a website. Using new software, the designer could complete each page in 1.25 hours, but it takes 8 hours to learn the software. How many web pages would the designer have to make in order to save time using the new software? Okay, so at what point are they going to be equal, or is it actually going to be beneficial? All right, so our first situation is that they're taking 1.5 hours to make a page. With the new software, it would only be 1.25 hours, but they would also have to spend 8 hours learning the new software, and we want to know when these are going to be equal. Okay, so we have our variables on both sides. The only thing I'm going to have to move is this one, because I don't have any other constants. When I subtract this, I get 0.25 hours equals 8. Then I have to divide by 0.25. Be careful. When I divide by a decimal, my number should actually get bigger. So the amount of hours it's going to take to save time using the new software would actually be 32 hours. 8 divided by 0.25 is actually 32. An office manager spent $650 on a new energy-saving copier that will reduce the monthly electric bill for the office from $112 to $88. And how many months will the copier pay for itself? All right, so $650 was how much they spent. We want to know when our savings is going to be better than that. Well, how much did they save? They went from 112 to 88. Whatever that is per month is what our savings is going to be. Okay, well, 112 minus 88 happens to be 24. So now it's just a one step, and I have to divide by 24. 650 divided by 24 gives us about 27 months, but it's actually just a tiny bit more. So I would say that it's about 28 months, because 27 isn't quite enough. All right, this is one you should try on your own quickly. If you pause it right here just to make sure that you get it. This is the last one of the day, and then come on back and you can watch me solve it. All right, day 1 of this assignment is on page 105.